Namaste. I welcome all teachers to the course on sample size determination. Let us assume that you have chosen an organization or a phenomena to study human resources effectiveness or organizational behavior. Quantitative or qualitative research are the two research paths you may choose based on your objectives and budget availability. Organizational behavior originated from the fact-based scientific experimentation, which requires manipulation of independent variables and to study their impact on the dependent variables. Here a very important point is, independent variables are those variables that researcher manipulates and he studies the impact of it on dependent variables. However, all phenomena may not be studied with scientific exploration. Therefore, there is a need for qualitative research. One of the most important tasks is determination of sample size in the quantitative research. Quantitative sample size determination is substantially different from that of qualitative methods. We will be discussing sample size determination under quantitative study. Please remember that you will not assume that this is a complete course on quantitative sample size determination. We have a lot of exciting self-directed learning material which is available. We will be discussing sample size determination under quantitative study. We will not assume that we will be studying every kind of quantitative sample size determination here, but you will be having a roadmap to have an idea how to go about doing sample size determination. Review of research articles indicate inappropriate, inadequate or excessive sampling sizes continue to impact the quality of inferences, thus inflating the cost and effect of doing research. In this research lecture, procedures for determining sample size are addressed to help the researchers to select appropriate sample size. Now let us discuss further sample size determination for quantitative research. Research starts with defining population consisting of sample units. The process of defining sample units and frames will be discussed in other lecture. Our objective will be to select a set of samples that are representative of the population and make inferences from the sample, and the inferences are generalized for the population. Therefore, we will be taking a small sample out of the population, study its characteristics and generalize for the population. Since we are using samples to make inferences for population, there will be sampling error. Thus, objective of sample size determination is to minimize sampling error. What is sampling error? Sampling error is the difference between a sample statistic used to estimate a population parameter and the actual but unknown value of the parameter. Very important. We are trying to use the sample statistic to estimate the population parameter. For example, if you want to estimate the proportion of the employees who are happy out of 1,000 employees in an organization, you determine your sample size as 118 employees by some method. You obtain 3.5 as an average score on a scale of 1.5. Then you are estimating the population people who are happy is as 3.5. But if you select the entire population and perform the same analysis, you will obtain an average of 3.8. Thus, there is an error of 3.8 minus 3.5.3. This is called sampling error. The effect of sampling error and response and non-response bias are usually not considered by researchers while choosing the sample size. Now, what should be the sample size for the following instances? I want you to just go through them. Now, study the voting preference of Indians. The population for the study is approximately 914.5 million voters in India. They are eligible voters. Now, next problem let us take. Attitude of employees of an automobile manufacturing unit with 20,000 workforce dispersed across different locations in India. Now, next problem is measuring happiness index of 600 employees working in an IT organization. The fourth one is measuring stress levels of 80 employees working in night shifts in an information technology enabled service firm. Now, tell me, what should be the sample size for all of them? Can it be the same? Can it be different? Or can it be very large or very small? Now, you have all these issues while thinking about the sample size. How much I have to take in order to really make a decision about the population? Observation questions. You will observe that population range between 90 million units to 60 units in 4 examples. What is the relationship of sample size to that of population size? Or should the research be concerned about the size of population? Now, a very important point we will be making, this sample size is not dependent on the population size. This is crucial statistical insight that is counterintuitive. Now, you will be going through the self-instruction material given by the Journal of Statistical Education, one of the most important reference, in order to know that you need not really take population size into consideration. You might be wondering why, how can I take 5,000 or 6,000 samples about India and come to a conclusion that X party or Y party is going to win? Yes, statistics are likely to help you in this regard. Now, let me make an assertion. Let us make a strong assertion. The standard error of the estimator depends on the size of the sample but not on the size of the population. However, some management researchers do talk about 5% or 10% of sample size of the population. For example, if the population is 2,000, probably 5% sample, 10% sample is, some researchers do talk about it. But by and large, we will be scientifically estimating the sample size with the discussion that we are going to do further. Now, we have to know about alpha error and beta error. A lot of times in your research, questions will be asked, what is your alpha error and beta error? Let me precisely define it for you. Alpha error is finding a difference that does not actually existing in the population. Alpha error and beta error are two important questions you will be asked in your research viva or while reporting your findings. Survey designs try to minimize both. Let me define alpha error. Alpha error is finding a difference that does not actually existing in the population. This is very important. We need to minimize this particular error, or else you will be finding a false positive in the population. On the other hand, beta error is failing to find a difference that is existing in the population. That is, you are trying to not able to find the difference when actually there is a difference existing. Therefore, alpha, let us be very clear about this particular dimension. Alpha error and beta error are not equal to 1 when you add them. In fact, both of them measure two different things. Therefore, you have to really be concerned about both the errors. But here in this lecture, we will be talking only about the alpha error. Later, we will be studying about the beta error and other related areas. What is the way to go about calculating the sample size? Let us start with the variables that are measured in a hypothetical job satisfaction study that is going to be conducted by you in a small factory. Now, the factory has 600 employees and you want to measure what is their job satisfaction. And you will be using a standardized questionnaires which are available and then trying to measure the job satisfaction. And you know very well that job satisfaction is a continuous variable that may be measured to the precision that you wish to measure. For example, you may wish to measure it as something like 3.5 out of a scale of 5. Therefore, approximately 70% of your employees are having a high job satisfaction. Therefore, job satisfaction is a continuous variable. Let us discuss primary variables of measurement. Job satisfaction is a continuous variable and you are going to use a 7-point scale in the instrument to measure job satisfaction. Now, we all know that job satisfaction is influenced by variables such as gender and race, which we call it as nominal variables, and or number of years of service, age group and educational qualification, which are categorical variables. Now, in our formula, a hypothetical formula we are going to decide where n, the sample size, is equal to some kind of a formula. There should be some numerator and a denominator. We would like to know what should go into the numerator and what should come in the denominator. Therefore, what variable I should use in the formula that we are going to form? Now, step 1 of our starting point. We will go through the recommendations given by Kochner in 1977. He is a statistician. He posited that one method of determining the sample size is to specify margin of error for the items that are regarded as most vital to the survey. Therefore, what are all the variables that are most vital to the survey? They are the primary variables. An estimate of sample size needed is first made separately for each one of these important items or important variables. If gender is a primary variable that is likely to impact the measurement of job satisfaction, that is primary variable by 7-point scale, it is likely to provide higher sample size. That means if you take only a dichotomous variable, you are likely to get more sample size. Thus, the researcher will have a range of n's, that is n is equal to sample size for different variables. We should find all the n's for different variables and select the highest n so that we obtain likely lowest sample error. Therefore, we have to find the primary variables and then find out what should be the sample size and find out which will give us the highest sample size we will be selecting. Now, one of the most important thing you have to consider is error estimation. That is your decision. Therefore, in error estimation, the risk the researcher is willing to accept in the research, which is called a margin of error, or the error the researcher thinks that his inferences about population are estimated. Therefore, if the actual population happens to be 70%, what kind of error I am likely to get and how to estimate that? The alpha level is the level of acceptable risk the researcher is willing to accept that the true margin of error exceeds the acceptable margin of error. That is, the probability that the differences revealed by the statistical analysis really do not exist is also known as type 1 error. The type 1 error is making inference that is not in existence. Carefully understand the difference between margin of error and the alpha level, for both require your thinking. What is margin of error? We will discuss little more in the next slide. Now, type 2 error, which is not addressed in this lecture, is a beta error. Type 2 error occurs when statistical procedures result in a judgment of no significant differences when these differences do indeed exceed. Type 2 error is unable to detect the differences when there are statistically significant differences exist. Now, let us start the thinking of sample size determination, and then let us think how I have to determine. To determine n, the sample size, what factors should be there in the numerator and what are all to be there in the denominator? How we design the formula? We are going to design our own formula. We will not go into the mathematical aspect, but try to intuitively understand the complete process. Therefore, n is equal to numerator and denominator, where n is the sample size. Think on what should be there. I want you to reflect. Then think, what should be there on the numerator, what should be there on the denominator, and then let us come to some kind of a conclusion. How do we go about determining the sample size? Alpha level in practice. Now, in practice, as a social science researcher or a management researcher, the alpha level used in determining the sample size in most social sciences research is 0.05 or 0.01. We will be using cochrane formula, which we will discuss in future slides, and use student t-value. We have studied to use student t-distribution for small sample size and for large sample size normal distribution. If you read most of the articles and the statistical outputs, you will observe t-value is being given by SPSS or all, or for larger samples, even 500,000 samples, you will be getting a t-value. I want you to reflect on this point for some time by reading the self-instruction manual, and here first is what, next is so what, and what next. For what is t-distribution and why every paper, 95% of the papers give t-distribution value, and so what, if you are giving that, how does it matter for me, and what next I have to do. These reflection points are very important for you for a better learning. Now, I have discussed the history of t-distribution in another self-instruction manual. The t-value is robust in the sense for sample sizes less than 60, it has a different value. For more than 120, it will approach normal distribution. The t-value for alpha level of 0.05 is 1.96 for sample size of above 120 sample units. For this, you should go through the self-instruction manual discussion on standard normal distribution, which I have given a elaborate discussion on what is standard normal distribution. What is this 1.96? Why it has no units? We will be having a wonderful thought process on standard normal table and then values of 1.96 and other related areas. Let me discuss something on. An alpha level of 0.05 is acceptable for most of your research reports and for publication in journals. However, use an alpha level of 0.10 or even 0.0 to quickly identify the statistical phenomena of relationships and differences. Therefore, this output you will be using for further research. Therefore, if you want a quick research within a week, you take a lesser alpha level, therefore 0.1 or even 0.20, and then go for the further study. In the case of critical studies, you should use alpha level of 0.01. This level of alpha level is used if the decisions have large financial and social implications. Acceptable margin of error. Now, what exactly is the acceptable margin of error? The acceptable margin of error for a continuous data and categorical data are different. If you want to detect variations in different variables such as quickness of grasping, ability to solve problems after going through the reading material prepared by SWAM, you will be having a most important variable is the education levels of the participants. I may hypothesize that +2 graduation, post-graduation will have influence on the learning ability and other variables. In this case, education levels will be influencing other variables and this will be our primary variable. Now, acceptable margin for a continuous variable. If you are measuring job satisfaction on a 7-point scale and assume it to be continuous variable, generally 3% margin of error is acceptable for continuous variables in social sciences. That means the researcher is confident, but the true mean of the 7-point scale is within plus or minus 0.21. You may be wondering, just what is this 3% margin of error has been converted into 0.21? The answer is you have to multiply 0.3 with the 7-point scale to obtain 0.21. So this you reflect. Therefore, there are 7-point scale, you are likely to make 0.03 error and you are likely to have an error level of 0.21 in your measurement of job satisfaction. I want you to reflect on this particular area and come out with why we should do this. Now, variance estimation. Now, entire statistics is study of variance. Other crucial component of sample size formula is the estimation of variance in the primary variables. As a researcher, you cannot control variance, but you can incorporate variance estimate in your research design. Now, how do I incorporate variance estimate about a research design? I really have not yet started my research. A very good question. There are 4 ways are suggested for estimating population variance for sample size determination. There are 4 stages to estimate sample size. First one is take samples in 2 stages. Use the results of first stage to determine how many samples are needed in the second sample based on the variance observed in the first sample. Number 2 is use pilot studies. Number 3 is use previous studies with similar population, and fourth one is use estimator based on some mathematical logic. Mostly any one of these 4 areas will help you to know what is the sample size being taken by other studies and by your own research. Now, we will have another kind of a measure known as sample standard deviation. To estimate the variance of a scaled variable, we use the following formula. S is equal to, now you have a continuous variable, and in a continuous variable you have 7-point scale, and these 7-point scale you have to distribute among 6 number of standard deviations. You all know that 6 number of standard deviations will cover on both sides of your mean, and you will get S is equal to 1.167. Now, you are able to explain the 98% of the variation, and this is the sample standard deviation. Now, basic samples. Now, let us come to the formula. Let us assume that a continuous variable is likely to play a role in measurement of job satisfaction. You and your organization decided to set up an alpha level at 0.05, plan to use 7-point scale and set acceptable level of error as 3% and has estimated standard deviation of scale 1.167. Then the formula N is given by T square into S square divided by D square, where D is the error that is acceptable to you. Therefore, it is 3%. Therefore, in a 7-point scale, it is 7 into 0.03 as I have already explained to you, and the t-value for 1 point, for the t-value that is given for an alpha level of 0.05 is 1.96. You square it, multiplied with the standard deviation that of the sample you have obtained, 1.67, and you get 118. Therefore, in the case of continuous variables, the required sample size is 118. Now, suitability of the sample size. This sample size will be suitable if the participants are captive audience or where you have control over selecting the random samples out of the population. Now, categorical data. Now, categorical data such as the education levels or gender of the participants are given, then the formula undergoes a little change. N is equal to T square multiplied by P into Q. Now, P is the proportion and P is the proportion. For example, the number of men and women approximately 0.5. Even if you do not know the proportions of the people, you can assume 0.5 because 0.5 multiplied by 0.5 will give you the highest value, 0.25. Any other lesser value for P will only give you a lesser value of, for example, if let us take P is equal to 0.4, it will be 0.4 into 0.6, it will be 0.24. Therefore, let us imagine that we should get a higher sample value so that we will not have many errors. We have P and Q divided by D square, that is the error that you have expected, and this is given as 384 units. Thus, in any research where categorical data is very important, the maximum sample size will be 384. And in the case of continuous variable, you can choose 118. I am not going to tell you that this is the sample size, but this is a good starting point for you to continue your research. Let me conclude. Here in this case, we have determined sample size by using intuition and trying to develop our own logic how it has been arrived at. But this is not one and all. You have good amount of study material, self-instruction manual and simulation exercises which will all help you to achieve better understanding of how to determine sample sizes. We are also going in depth into areas of how in qualitative study you will have a sample size determination, and in the case of big data analytics, what should be the sample size? Therefore, those are all the areas you will be finding it in various quadrants of 4Q learning, and in the process you can also evaluate yourself and identify your strengths and pass it on to your students. Namaste.